All right, everyone, we are back, and we are going to go through our P-Set 5 and look at a problem that we were working with last time. So, now we're doing some hypothesis testing. Are A and B significantly different at a 1% significance level? And then we'll do B and C, and then et cetera, et cetera. In our response, we should give us the expected p-value range as well. So, let's go ahead and get started with our protocol for hypothesis testing. So are A and B significantly different at a 1% significance level? So what is our first step in any hypothesis testing? Well, we want to know our H naught. So we're going to say, is our mu of A equal to our mu of B? And actually, we're comparing essentially two of these. So we're going to do this t-test comparison that we did previously. Our alternative hypothesis is A is not different from B. Our third step is, well, what is our new? Our new, we are going to actually have to program that in here. So, and actually to calculate. So we need to find, actually, let's go ahead and pull out our lecture 5. So we are actually going to build and use our function from lecture in R in order to calculate that. So let's go ahead. We'll bring this to the side. So our new value, we have our t-test comp, we have our new comp, and we're just going to go new comp, and then it's going to be, what's our S1? Actually, and let's go ahead and define that. So let's say NA goes to 49. Let's say XA goes to 29. SA goes to 1.8. Let's say NB goes to 14. Let's say XB goes to 38. Deviation of 5.6. SB goes to 5.6. And let's say NC goes to 27. Is that correct? Yes, it is. XC goes to 36. And finally, SC goes to 3.1. So I'm going to enter all these. Boom, 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 boom. So our new comp is going to be, let's go ahead and write that again. So S1, S2, N1, N2. So SA, SB, NA, NB. Our new comp is, let's just call it 14. So our new is approximately 14. 1, 4. So, fourth step, what is our T experimental? And then fifth step is going to be T. We're looking at a 1% significant level. Are they different? So it's going to be our alpha is equal to 0.01 divided by 2. So 0.005 of 14. We can find that value right now. So let's go ahead and we can pull up from last time. T of 005. And then let's look at 14. 2.977. 2.977. T experimental. We can calculate that with our function as well. So T test comp. X1, X2, S1. Okay, so we'll just say XA, XB, and then we can copy all of this. And then it's minus 0.592 equals minus, actually let's look at here, minus 5.9. So if we're looking at our hypothesis testing, we're doing the two-sided. So we are in the reject H0 region. So we will reject that H0 value. So we can actually go ahead. So we're going to be over here. So because we fall way, 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 way to the left there. So we're in the reject H0 region. So we can see, actually, yeah, fantastic. Now, the question is, what is going to be the p-value here? So the p-value is going to tell us, again, it depends on our confidence level. So if we're in the reject H0 region, our p-value is going to be less than 0.005. There we go. All right, now let's do the same thing for the next couple problems. So we're going to go ahead and see, is B greater than C? So let's do, here we go here. Let's do XB, XC, SB, SC, and B, and C. So that's our t-test value. This would be our, oops. We have an error here because this one is incorrect. So now we can kind of adjust our profile here a little bit. So now we're looking at a greater than. So let's go ahead and shift this. So now we're saying, is this greater than? Basically, these aren't going to be affected too much, but now we're looking at a right side test. So now our t is 1.24 experimental. So 1.24. And then our nu is about 17. So now when we're looking at our basically, when we look at this, what we're going to do here is we're going to say t, and we're looking at 5% significance. We're not dividing by 2 because now we're looking at a greater than. So our alpha is going to be 0.05 of 17 is going to be equal to what? Let's pull up. So 0.5, 17, 0.5, 17. That's going to be 1.74. So if we look at our hypothesis testing, let's go ahead and look up that here. We're looking at the right side test. So we are falling on the do not reject. So our p-value is going to be greater than 0.05. Because again, we're falling in that do not reject region. All right. And then finally, is C less than A at a 99% confidence level or interval? So let's do C and A. So let's go. I'm going to pull up our R. So let's do XC, XA, SC, SA, NC, and A. We'll go ahead and steal this here. Do the same thing. Now we're doing a left-sided test. And boom, boom. So we're doing 10.7. That's correct. And then I'm going to say that our nu is basically just infinity. And we're going to cross this out now. So we're going to say that our t of 0.01, and then we're going to say infinity is equal to, and actually it's, 0.01 because it's left-tailed. So we're going to click here, 0.01, infinity 2.326. So we're already in the greater region. So let's go ahead and look here. So for a left-tailed test, we are going to be in, actually it's going to be a minus because it's left-tailed. Let's go ahead and I want to look at the, just going to confirm my R test result. Good. So if we're looking at the left-tailed, we're definitely big, do not reject, so our p-value is going to be much greater than 0.01. Fantastic. So this is done. Now, does C, we're going to have a little bit of a different steps here. Let's see. I love that this is doing this now. You can just cross out and it's deleting it. Fantastic. Anyways, does C come from a population with a mean of this? So again, very similar. So now we're saying, is our mu equal to 39S? So it's a two-tailed test. Our alternative is that it's not. Our third step is going to be our basically confidence interval. So what's our confidence? So it's basically our alpha is going to be equal to 0.01, but we got to divide that by 2. So our alpha in that value is going to be 0.05. 4, what's our t experimental? And then 5, we're going to have our t of 0.005. And our nu, because it's C, our nu is going to be 26. So we know what that value is. 26. And then 0.005, 2.779. So 2.779. And then let's go ahead and calculate our t experimental. We should have that function in R as well. I'll basically break that down in here. TXP is our function. So let's do our t experimental. And how TXP. So our x bar minus our mu naught. So our x bar is going to be for C. It's going to be XC. Then it's going to be our mu naught, which is 39. And then SC. And then NC. When we do that, it's minus 0.502, which makes sense. Minus 0.502. Minus 5.02, or yeah, 5.02. So if we go ahead and look at our hypothesis testing, we're doing two-tailed. So we are definitely in the reject. So that means our p-value is going to be less than 0.005. Fantastic. So this one's done. What about a left-tailed test for B? So again, this we kind of know, left-tailed test. What is our here? We're looking at a alpha equals 0.1. And then we're looking at a t of 0.1. I'm just going to erase all this stuff. So t of 0.1, and then our b is going to be 13, and that's going to equal, let me pull this up, 13.1, 1.35. But it's be negative because it's left-tailed. So let's go ahead and calculate our t experimental. So now we're looking at XB. Does it come from a mean of less than 44? SB, NB, minus 4.0. So t experimental minus 4.0. If we look at that, for the left tail, it's way to the left. It's a reject, so p is less than 0.1. Good. I'm just crossing these out as we go. Does A come from a population greater than 32 seconds? So now it's a right-tailed test. Doesn't give us any information so that we know it's 0.05. So we know then we're going to be looking at a t of 0.05. A is large, so it's infinity. So that's going to equal, let's see here, t of 05, infinity, 1.645, positive. And now our t experimental is, let's go back to R. So it's going to be XA, 32, SA, NA, minus 11. And if we look at our, so if it's minus 11, that's going to be a do not reject, and that's p-value is going to be much larger than 0.05. There we go. Fantastic. Now we have some data files. So 3 data files. Are any of these pairs statistically significant? So let's go ahead and pull up our R. And let's go ahead and let's work with our data files. So we're going to open up our p-set 5. We're going to be working with the data files we're working at last time, but we're going to change we're going to set as working directory. We're going to copy this, feed it in. So now what we're going to do, read in the files like last time, Control Enter, 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 set our working directory, read our data files, and then are we told, let's go ahead and look at our questions. We'll hide these a little bit for now. Let's bring these in. Good. So, are any of these pairs statistically significant? So let's compare 1 and 2, 3 and 2, and 1 and 3 at the 95% confidence interval. So we'll test. What is this saying? Basically, our p-value is extremely small. So basically, what is it saying? The alternative hypothesis is this. So if we're looking at our p-value, so our p-value is less than 0.025, so we are in the do not reject regime. And we can do the same thing for 3 and 2. Do not reject, and then we do reject 1 and 3. So, fantastic. We have some additional questions here. Let's pull up, or let's actually go to the side. Does 1 come from a population with a mean greater than 126 at 95% confidence interval? So remember, we need to be less than 0.01, so let's go ahead and click there. So our p-value is 1, so that is definitely a, let's see, excuse me, actually. Here, let's fall in. Actually, we were in the reject regime, excuse me. So let's go back over here. I misspoke. P-value is less than our 0.025. We are in the reject. Here, reject. And then this one was the do not reject regime. And then here as well, the greater than 126, that is definitely a do not reject. And we can kind of understand PS41, bracket 2. Let's look at the mean. So does it come from mean greater than 126? Our mean is 4, so definitely not. So what about, let's go ahead and go to here. Let's go to our next question. What about mean, let's see, does file 2 come with a mean less than 120? That value is basically 0. So again, that is going to be, if we're looking at our hypothesis testing, that's going to be a big old reject as well. Left-tailed, we are in the do not reject regime, or we're in the reject regime for sure. Excellent. And then finally, does file 3 come with a mean of 125? That's two-sided, and we can go ahead and see there. And you can see the t value as well. Here, that is a reject as well. There you go. So that's our p-set 5 solution. See you next time. Thanks. Bye.